Hi and welcome to this video where I'm going to be summarising the physical properties of different types of solids which are required as part of NCEA Level 2 Chemistry, that is standard AS 91164 Structure and Bonding. This particularly covers 4 types of solids, which are covalent ionic solids, such as sodium chloride, which are made of ions held together by ionic bonds. Metallic solids, such as copper, iron, or gold, which are made of atoms held together by metallic bonds. Covalent network solids, such as diamond, or graphite, or quartz, which are made of atoms held together by covalent bonds. And molecular solids, such as water, which are made of molecules held together by intermolecular bonds. Now, if you want more discussion on any of these types of solids, there are separate videos on each one, which I encourage you to go and look at. And the properties that we consider in this standard are really 4 physical properties. So strength or hardness, which is things like, is it brittle, malleable, ductile, etc. Solubility in water and non-polar solvents, melting and boiling point, and electrical conductivity. And all of these physical properties depend on the types of bonding that are present within the molecule. Or compound, not necessarily a molecule. So different compounds have different types of bonding present, and therefore they have different physical properties. We're not going to talk about the chemical properties in this situation because those become more complex yet again. Okay, so what I'm going to do is look at each of these properties one at a time, talk about the key factors that you need to consider and compare those different types of solids. So the first one I'm going to look at, because it's the most simple, is melting and boiling point. And really the key thing that you need to be aware of with melting and boiling point is that it is all about the breaking of bonds between the particles. Whether those particles are atoms, ions, or molecules, it doesn't matter. The point is that when you melt or boil something, you have to break those bonds between the particles. You do this by adding energy in the form of heat. Now logically, the stronger the bonds between those particles, the more heat energy is going to be required to break them apart. So really what melting and boiling point is a surrogate measure of how strong the bonds between the particles are. Now, roughly in order of strength, intermolecular bonds are the weakest. So molecular substances typically have lower melting and boiling points than any of the others. They do vary depending on both the size of the molecule and the polarity of the molecule. So larger molecules tend to have stronger intermolecular forces than smaller molecules. More polar molecules have stronger intermolecular forces than less polar molecules. Moving up, then ionic and metallic solids are both held together by electrostatic attractions between charged particles, so between ions in an ionic solid or between the nuclei and the valence electrons in a metallic solid. These electrostatic attractions are relatively strong, and so ionic and metallic solids typically have reasonably high melting and boiling points. Typically, for the majority of them, the melting and boiling points would range between sort of 500 and 1000 degrees Celsius, give or take a bit. The covalent network solids have all the atoms connected by covalent bonds. Covalent bonds are the strongest type of bonding that we have available to us, and therefore the covalent network solids have the highest melting and boiling points of these different types of solids, because to melt or boil them, really you have to break these covalent bonds, and that requires a significant amount of energy. So roughly, molecules have the lowest melting and boiling points, ionic compounds and metals have the next, and covalent network solids have the highest melting and boiling point, and that is comparable to the strength of the forces between the particles. Okay, solubility in water is an interesting one. So water is a polar molecule. It has positive and negative ends. This means that things that also have positive and negative parts are likely to dissolve in water. That tends to be ionic solids and polar molecules. Both will dissolve fairly well in water. Metals and covalent network solids generally do not. Now, what it comes down to when we talk about solubility is that the attraction between the thing you are dissolving, that is the solute, and the solvent, usually water, the attractions between those two types of particles have to be stronger than the attractions within those substances. So, between the ions themselves and water, So if the attraction, say with an ionic compound, if the attraction between the ions and the water is greater than between the positive and negative ions or between the water molecules themselves, then it'll dissolve. If it's not, it won't. That's what it comes down to. It's all about those attractions. Okay, electrical conductivity is pretty straightforward. And electrical conductivity comes down to the question of, are there freely moving charged particles within this substance? If there are freely moving charged particles, then electricity can be conducted. And if there are no freely moving charged particles, then it cannot. So, although ionic solids contain charged particles, they contain cations and anions, those particles are fixed in place and can't move. So ionic solids don't conduct electricity. But if you take your ionic solid and you then melt it, so it's now an ionic liquid, or you dissolve it in water, so it's an aqueous solution, then those charged particles, those ions, are freely able to move around, and therefore that substance will conduct electricity. Metals and graphite both contain delocalized electrons, which means that they are able to easily conduct electricity. While covalent network solids and molecular substances don't have charged particles, let alone freely moving charged particles, and therefore will not conduct electricity. So that's electrical conductivity. The last one is probably the most complex to try and explain, and that is about hardness, malleability, ductility, brittleness, etc. Now, just a quick recap on definitions. So brittle is something that if you hit it, it will shatter. I think glass or crystals, you whack them with a hammer, they'll break up into lots of little pieces. So that's brittle. Hard and soft is basically about, can you deform it if you squish it? So if you take it, put it in your fist, can you squeeze it and deform it? Okay, so things can be brittle but hard, which glass is. They can be soft but malleable or ductile. Malleable is the ability to make it change shape. Ductile is the ability to stretch it into a wire. Okay, so this all comes down to the directionality of the bonds in that substance. Okay, so if the bonds are rigid and directional, so think ionic solids, covalent network solids, then if you apply a force, then they will cause the bonds to break, and that will cause the solid to break or shatter, which usually means that it becomes brittle. Some things are easier to break the bonds than others. If the bonds are non-directional, like those in graphite or in a metal, then that will allow the particles, the atoms, or the molecules, not molecules, the atoms, or the layers in graphite to move over each other, while the bonds simply rearrange from one atom to the next, and that will allow it to be shaped or moved. So that is a very, very brief run through of the different types of properties and how the different types of substances are affected by that. You'll notice when it comes to strength, I haven't talked about molecular substances at all, because actually that discussion really is not particularly relevant. The next video will talk about some classic exam questions and how you go about answering those. So I hope to see you soon. Thanks, bye.